Okay, so here's section 8-4, angles of elevation and depression. Think about what an elevator does. An elevator takes you up to the next floor, and depression is something that you feel when you're down. Depression goes down. So when you're looking at an angle of elevation in a word problem, it is an angle formed by any horizontal line, either where you're standing or where your eyesight is, and the line of sight to an object above the line. Elevation is going looking upwards. So copy that in. An angle of depression is an angle formed by the horizontal line and the line of sight to an object below that line. So angle of depression is opening downwards. So you're standing on top of a house and you're looking down at something on the ground. Here for elevation, you're standing on the ground and you're looking up to the top of the Eiffel Tower. So as we're doing word problems, it's important to remember these two words so you can put the X in the right place. So for this first example, I don't want you to do any writing. I just want you to watch it with me. Just put your pencils down and observe how we're going to do this problem, just like you've done in the past. Draw a picture of what's going on, then put the numbers in. Then we'll choose a method that works, we'll make an equation, we'll solve it, and we'll label. So suppose you stand at the top of a ski slope and you look down at the bottom. So you're standing up here up at the top. This is you. And you're getting ready to ski down and there's a slope and then you go to the bottom of the hill. All right, the angle of depression is 25 degrees. That means the angle looking downwards. So this is where you are. There's a line, an imaginary line of sight going straight across, and the angle of depression goes down from there. And it says that the angle of depression is 25 degrees. So we'll put 25 right there. Now it says the skier has to ski 132 feet to reach the bottom. So the skier is going downhill like this, and they have to go 132 feet in order to reach the bottom. The question, that's where your X always goes. Estimate the vertical drop. Vertical. Think vertical means this way. If you were to drop straight down, the vertical drop, that's what they want us to find. So that's where the X is. Now we're studying triangles, so we need to look at this. We need to turn it into a triangle. So the easiest thing to do is to just close off one of these sections. You could go like this, straight across, or you could have drawn a triangle over there. So in this triangle, this side is X. This is your right angle. The hypotenuse is 132, but this 25 degrees isn't in the triangle yet. So you have to remember alternate interior angles. This is 25 degrees. What other angle in this triangle would equal 25 degrees? Think about alternate interior angles. It goes right here, 25 degrees. So the method, we have to choose a method to use. I'm dealing with sides and in angles, so I'm going to use SOHCAHTOA. And with that, I'm going to set up an equation using 25 degrees as my focus angle right there. I want the O, the X is the opposite. I know the H, the hypotenuse, so I'm going to use sine. The sine of the focus angle 25 degrees equals the opposite X over hypotenuse 132. Since I know the degrees, I am going to cross multiply. And I'm going to use the regular button, not the inverse button. So put it over 1, and we're going to do X times 1 equals 132 times the sine of 25 degrees. And we get, make sure you're in degrees, 132 times 25 sine, and don't forget to hit equal so it can finish multiplying. 55.7856. It does not tell me how to round it, so I can choose for myself. I'm going to do the nearest tenth of a foot, 55.8. feet. So that's right here. This would be 55.8 feet. All right, pick up your pencils and do the last two examples in the notes with me on the front side. And just think about what's happening and the picture we would have to draw. An air traffic controller at an airport sights a plane at an angle of elevation that's looking upwards of 41 degrees. Okay, so there's a guy at the airport. He's on the ground. Here's your ground. And here's your airport. And there's a guy in the airport. He's an air traffic controller. He sights a plane. The airplane is in the sky. Draw yourself an airplane, but whatever you do, don't laugh at mine. That's my airplane there. And that's it. There's nothing else to draw. The guy sitting at the airport looks up and sees a plane. Now let's put in the math. An air traffic controller at the airport sights a plane at an angle of elevation. So he's there. He's looking upwards for an angle of elevation looking up of 41 degrees. The pilot reports that the plane's altitude. Think about what altitude means. In the real world, altitude means height, straight up. So this is the altitude right here. The height of the airplane above the ground, directly above the ground. That's 4,000 feet. Question, this is where we put our X. What is the horizontal distance? This is vertical, this is horizontal. So what's the horizontal distance between the plane and the airport? Right there, between the plane and the guy sitting at the airport. That's it. You make your picture, now you just solve it. What's your focus angle? 41 degrees. We're going to use SOHCAHTOA because we're dealing with an angle here. So this becomes your opposite, this is your adjacent, and that means tangent. The tangent of the focus angle, 41 degrees, equals opposite 4,000 over adjacent x. I know the degrees, so I'm going to cross multiply, but when I do it, x times the tangent of 41, I realize that I'm not done yet because x isn't alone. So I'm going to divide both sides by the tangent of 41. And then I can figure out what my x is. So use your own calculator and check your work against mine. I start off with 4,000 divided by 41 tangent, but that's just the tangent of 41. I have to equals to finish dividing 4,601.47. I'm going to go back and read the directions to see if they told me how to round it. What is the horizontal distance between the plane and the airport? They were not specific about rounding, so I'm going to say 4,601.5. About 4,601.5 feet. And if that went too fast for you, you can always go back and rewind and pause and slow it down, as it will help you. Last example, number 2. A forest ranger in a 90-foot observation tower sees a fire. The angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? So what's happening is there's a fire tower up in the air. Okay, it's a tower. And there's a guy standing up on top looking out to make sure that it's safe. All right, he's up here looking down and he sees a fire. Okay, it's going to be like a forest fire there. So he's looking down at that. He's looking and he's seeing a fire right there. And there's our triangle. So now let's put the numbers in. A forest ranger in a 90-foot observation tower. That's how tall the tower is, 90 feet. He sees the fire down on the ground. The angle of depression. Depression has to start at a horizontal line and it has to go downwards from there. So that's what your angle of depression looks like. It goes downwards. And it says the angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? The horizontal distance between the tower and the fire is right there. Okay, so we need to figure out how to solve this now. I would use SOHCAHTOA because we have an angle here, but that angle's not in the triangle yet. Here's the triangle, so all we have to do is use alternate interior angles. If this angle is 7 degrees, then this angle is 7 degrees. Use that as your focus angle. That means this is the opposite, this is the adjacent, which means we use tangent. The tangent of 7 degrees is 90 over x. Since I know the degrees, I'm going to cross multiply it. X times the tangent of 7 equals 90, but x isn't alone yet, so I need to divide by the tangent of 7. Divide by the tangent of 7. And x is going to be, I need to look back at the problem to see if they want me to round it a particular way. What is the horizontal distance between the tower and the fire? They don't specify, so I'll probably do nearest tenth. So I'm going to do 90 divided by the tangent of 7. So 7 tangent, and I have to hit equals. So it's 732.99. So I guess that's going to make about 733 feet. The directions don't tell me, so I can round it to whatever makes sense to me. Okay, look back over that if you need to review it, but your homework for tonight is to turn to the back side and do the last page of your notes. There's 7 problems there. Work on it together right now and finish it at home if you need to.